This is a distance equals rate times time problem where we're trying to find the speed of the airplane. The question reads, an airplane flying with the wind takes 4 hours with a 40 mile per hour tailwind. The return trip takes 7 hours flying against the wind. What is the speed of the airplane in still air? Right? So remember, when you're in an airplane and if it has a tailwind, like we're talking about here, that means that it's pushing the airplane faster. The wind is coming from behind and it's pushing it 40 miles an hour faster than what it's really going in still air. And so if you have a headwind, though, if you're flying against the wind, then it's slowing you down. All right, so those are important things to know when we're trying to set up this problem. I like to use a table when I'm setting up these type of problems. I have the distance, rate, and time along the top, and along the left side I have the information about with the wind and against the wind. Okay, and the distance on this is an airplane flying to a destination and then flying back. And so this is going to be the same number of miles. The distance is going to be the same. So we'll call the distance D, and we'll put D on both of those because we know it's going to be the same distance. Now the rate is something you've got to think about a little bit more. Remember, with the rate, it is made up of two different things. When we're talking about airplanes, we're talking about the speed of the plane, all right, so the speed of the plane in still air, plus or minus the speed of the wind. So those two things together are making the rate. And so that's what we need to think of here when we're filling in rate. All right, so we don't know what the speed of the plane is in still air. That's what we're trying to find. All right, so let's call that R. And so we know with the wind, that's going to be pushing it faster, right? And so that's going to be the R plus 40. And then against the wind, that's slowing you down. So the rate of the plane minus the speed of the wind. So R minus 40 on that. And then the time is given to us in here. So it says with the wind takes 4 hours, and against the wind is going to take 7 hours. Okay, so now we can set up these two equations, remembering that it's distance equals rate times time is the formula we're going to be using here. So the first one's going to say distance, so D equals the rate times the time, or I could say the time times the rate. So I'm going to say 4 times R plus 40. And then on the bottom equation, D equals 7 times R minus 40. And then I know that my D, right, the distance, is the same. And so on this one, I would use the substitution method to go ahead and solve this, remembering that D equals all of this. So I can put all of that in place of D in my first equation. So let's write it down that way. So I have 7 times R minus 40 equals 4 times R plus 40. All right, let's go ahead and distribute through. Clear those parentheses. When I do that, I have 7R minus 280 equals 4R plus 160. All right, and now I want to get the R's on one side and the numbers on the other. So I'm going to go ahead and subtract my 4R over to the left, and then I'm going to add my 280. So when I do that, I can see I got rid of those, leaving me with 7R minus 4R is 3R. Equals 160 plus 280 is going to give us 440. Okay. And then I need to divide by 3 to get the r by itself so I can figure out this. Remember, this r stands for the rate of the plane, right? And when I put this into my calculator, I get a decimal answer, but remember to always go back up to the original question and find out where we need to round that answer to. So when I do that, I'll get r equals 147 miles per hour. Right? Or in words, I can say the speed of the plane in still air is 147 miles per hour. All right, so that's if there wasn't a headwind or a tailwind, it would be going 147 miles per hour.